Good morning. A very warm welcome to all of you, whether you are at work or at home. But one thing is for sure, we welcome you to the first iSMA Summit online event, aimed specifically at the UK and Irish market. We hope to meet you face to face very soon, but today please sit back with a cup of morning coffee or tea and stay with us. What awaits you for the next 2 hours? Lots of interesting and practical presentations from our fantastic partners. And at the end, we invite you to chat with in the virtual rooms with us and our distributors. Together with the co-organizers of the summit, the iSMA distributors in the UK and Ireland, whom we warmly welcome and thank you for their commitment and support, we will try to discuss the future of the BMS and present how iSMA device can fill it. A few words of introduction about Gc5 for those who haven't met us yet. Global Control 5 is the Polish leader in hardware and software technology. We design and manufacture intelligent building automation management systems under our own brand iSMA, which stands for Intelligent Solution Managing Automation. The iSMA offer contains hybrid IoT controllers based on Niagara framework, automation controllers, DDC and Funcal unit controllers, HMI panels, I/O modules, along with a management and supervisory software. Okay, so please don't set your laptops and phones. Here we go. Firstly, I would like to invite on the stage Adam Półgrabia, Global Control 5 CEO. Hi, Adam.
Hi, Alex.
Good luck.
Thank you. A warm welcome to all of you attending the first edition of iSMA Summit. The concept of this event has been maturing in our heads for quite some time. And of course, in the original and dream version, it was supposed to be stationary. However, the year 2020 as well as 2021 changed everything and forced us all to adapt quickly to the new conditions in which we have to operate. This recent time, so dominated by COVID-19, has contributed to increased activity of the companies in online channels. I'm therefore delighted to welcome everyone to iSMA Summit 2021 and hope you will appreciate the convenience of attending it, whether from work, home, or anywhere via virtual platform. Moreover, I'd like to express my cordial greeting to our distributors from the UK, Forest Rock and OneSite Solution, and from Ireland, Intelligent Building Controls, and our special guests, Paul Rogers from Tridium and Roger Woodward, a member of our supervisory board. In the studio, together with me, there are Marcin Ploski, VP of Business Development, Monika Musielak, Solution Manager, and Alex Wyrozumski, whom you have already had the opportunity to see. Finally, I would like to extend a very warm welcome to all of you who have found the will and time to join us today. A future powered by Edge. This is the motto of today's conference. After decades of stagnation, BMS is finally embracing changes in technology. These changes are forcing a technical and commercial shift from edge devices to cloud services, and Roger Woodward will give you more insight into this topic. Next, the cloud theme will be continued by Steve from OneSite Solution, who will focus on showing advantages of cloud-based systems over against a more traditional on-premise application. The following speaker, Rich from IBC, will give his perspective on the evolution of BMS. His presentation revolves around the development and growth of much smarter products. He will be followed by Nick Cooper from Forest Rock, who will demonstrate the benefits of SkySpark Analytics and Enfo Energy Manager in practice. Continuing the theme of data collection and processing, Paul Roger from Tridium will discuss market trends and solutions to meet this demand. And last but not least, Monica and Marcin will show our vision for the growth and future powered by iSMA Edge. And they will also give us a number of reasons why we should build this future together. So please stay with us today. Thank you for your attention. Thank you.
I would like to welcome our first speaker, Roger Woodward, who has been with Global Control 5 since 2019 as a member of the supervisory board. Roger has 30 years of experience and is a recipient of the Lifetime Achievement Award from the Industry Association. Today, Roger is going to tell us about the benefits of moving BMS to the cloud and what challenges this pose to the edge device. Roger, I give you the floor.
Hi, good morning, and thank you for the introduction, Oleg. As mentioned, my name is Roger Woodward. I am on the supervisory board with Gc5 and was formerly with Tridium as their VP of EMEA. I'm now actually supporting a number of companies, both strategically and helping them to grow internationally. Today, I'm going to talk about edge to cloud and really where we are. Is it happening or not? So first, let me share my screen. Okay. So here is a typical example of a kind of edge to cloud type concept of slide, showing the IoT, which I think we're all pretty familiar with now, talking lots of different devices, talking to one another, or actually coming together to actually provide data out. Edge computing, which is really the real-time data processing locally on site, where data is actually handled, and then the cloud, where the data is served up to from site. And the real-time data processing takes place here at the edge. How does that relate to our own industry? Well, if we look on the left here, that Internet of Things is really the devices that are connected, sensors, equipment, could be anything from fire alarms to lighting, meters, and so on. And then in the middle here, we have all the services we traditionally see in a building. The HVAC and the lighting, kind of always connected through to the BMS. But then again, that also connects through to the fire, and to shut plant down. Quite often, security and alarms from lifts and the metering also connect through as one. And this is where the real-time data processing takes place in our industry through the control system and the BMS. But we all know that kind of that's where it stops today. We have all this information connecting through to maybe a supervisor. But unfortunately, that supervisor quite often sits in the basement with about 500 alarms and nobody doing anything with all that data we've been processing. And we see here the concept of the building IoT and edge as we see it today. And you got, I would argue that the IoT is already taking place in buildings. Is the chiller not connected to the pump? The pump's connected to the air handling units, and they are actually, connected via perhaps the BMS to the fire system, so that when the alarm comes in from a fire, we shut it down and we're not feeding the fire. We optimize the buildings to bring them on and turn them off early. Whenever people are moving, perhaps from the cleaner, the lighting comes on and so on. So we're already doing a lot of that, and we're connecting, devices to devices and systems to systems and people to data. And we are already metering and collecting and monitoring. However, as I mentioned, I think that's where we stop today. And where we're moving to is connect it further through to the cloud, putting data into the hands of people who can perhaps do something with that information. And that might well be, people in prop tech. It could be the maintenance management company. It could be facility management company, or people dealing with the security and so on. At least we're now getting that data from site to the people who can perhaps use it. I think here is a sketch which may help you explain a little bit more. I think we're seeing lots of buildings being connected together, multi-site connectivity, where the data is brought back and normalized and brought to a cloud, perhaps AWS, maybe Azure. It could be any cloud where the data can be, set. And from that, you've actually got lots of services: energy management, asset management, maintenance, lease management, space management, and so on, all connected through. And these could be different service providers taking from the same database. And so we're not restricted to one supplier. It could be anybody. And I think we are now seeing a migration of the BMS supervisor moving off-site so that it can handle multiple things, and perhaps putting in, working through the facility management people. And I think that lots of those changes are forcing things like dashboards being more important than some of the heavy graphics that we've had in the past. But it's very important that, in this chain, that the data is open and secure. We're seeing that change where we must have secure buildings, and it must be open so that anybody can get access to the data and can interact with other solutions. We're seeing a huge amount of services now actually being brought to the marketplace, and the customers are getting smarter. It's the customers who are actually beginning to drive some of these things. We have things like BIM, obviously the maintenance, traditionally the maintenance management package that the FMs use. People are looking for things like visitor management and space utilization due to COVID. And some of these things are being accelerated by COVID. And I think the things like the JLL concept of 330, 300, of where 3 is for the energy, 30 is for the assets, and 300 as the people, is really important to the customer, because they're actually recognizing that their staff are the major asset and they've got to be looked after. So well-being and their access to the environment they're working in is good. And I think that the things like space utilization are being introduced. And I think we'll actually see a change in buildings, which we perhaps talk a little bit about later on. On the left, you can see a graph of where, over just the past few years, huge amounts of money have been pumped into what's called prop tech and CRE tech, which is really, commercial real estate and the services that go in it, which is the area we work in, is probably about 40% of the investment that's actually been made there. And some of those are significant. So here's a good example, and I think this kind of brings home and something that we might all be able to relate to. On the left, it shows you all those services we talked about earlier. But when someone's trying to manage a building, they need to be able to get access to that information if they're going to service the customer properly. So the first thing that happens is we might normalize that data and provide connectivity to the cloud. And one sort of package that people will be aware of is the maintenance management, the computerized maintenance management package. And you can imagine that now if the alarms come in, instead of just going into that PC, we can actually put them into a package that deals with it. So suddenly the alarms are triaged. How important is that alarm? Is it a filter blocked? Is it a chiller down? Is the lift stuck? And so on. And once that's in there, we can combine it with reactive and predictive alarms, condition-based, how important before we actually get out, and should we be carrying out some of those activities if we're going to go to site. Along with that, you can actually see that we can actually apply analytics to this information by weighting it, counting it, has this happened before, and grouping it perhaps with some of these more condition-based type alarms here. And then we can tie it into the asset. We have full day information about the asset, maybe the chiller, the type of chiller it is, and also perhaps the people that are dealing with the maintenance and the handling of any problems we have. Once that's done, we can then actually generate the works order automatically and dynamically. And that can go out to our service provider, who actually is now able to get his works order almost instantaneously from when the thing happened. He can then actually assess from that what needs to be done. He's got the information on the plant or the piece of equipment. He can have a look and make sure that from the alarm and the information provided by the CMMS and the asset, that perhaps the alarm has come through that's saying, yes, it is a filter, but it's this type of filter. And it's, it's pointless visiting site without that filter, because traditionally we'd have gone to site, find out what the problem is, come back again, find out whether we got the part, did we put the right engineer on site to do that. Now we know before we go, we do one visit with the right engineer and right part. That gives us a fully integrated workflow and allows us to bring in all sorts of other services like asset mapping, BIM, and digital twins, and so on, to actually make sure we have a smooth, efficient running of our building and recording what happens. This minimizes the downtime for the customer and also makes all the services that we're providing much more efficient, for the service provider and everybody in the chain. I think it can be seen from this example, just by getting that data off site into the hands of people with additional things like AI and analytics, and perhaps even more things like machine learning, we can actually put on what the asset is and provide the customer with a great performance. And we can see eventually they come back and we can get our maintenance validation. So where are we in this chain? We can actually see here, I think on the left are our visionaries. We have our pragmatists, but I believe right now we're in a chasm. I think it's a problem for us in that we have the technology and the customer is getting smarter, demanding some of those things that we saw, all the different services, and our goal would be obviously to try and bring in the pragmatists. But I think this is not a technology issue anymore. We have all the software that we actually need, of course, that will go on being developed. I think we have to look at the supply chain. We're seeing the people like real estate trusts actually bringing in people like MSIs to actually master system integrators to make sure that all those services they want are delivered, because I think the supply chain in between is yet to adapt to be able to actually satisfy the need for the customer's demands. A good example for this may be models like SaaS. And if a chiller manufacturer came along and said, hey, here's a chiller, it costs nothing, but we're going to be charging the customer on the use of cold water. How does that work for today's chain? The first thing that's going to happen is the supply chain can't mark that up. So they're told, no, you just provide the chiller in a traditional route. So I think those are the sorts of things we've got to look at. to change. And that chasm has got to come. I think COVID's accelerated that. I think the customer being smarter is doing that. I think people like MSIs are able now to bridge the gap between the customer and the people who are providing the services. And they're also beginning to actually work with the consultants and contractors to maybe bring that on. And I think, we can see that the need for that gap being closed is very important. And I do believe the time is now. So I think there's a good opportunity for us now to actually move on and complete, that kind of push for data to reach from the edge to the cloud. We have the technology, we have the devices. Today you'll see more from Gc5 on what they're doing with the edge devices. And we know cloud services are beginning to be asked for by the customer. So hopefully we'll be able to actually see the conclusion of the bringing together edge and cloud to provide customers with what they actually need. Okay, so I'd like to thank you for your time today. I hope you really enjoy the rest of the summit. There's a lot more to be talked about. And right now I'd like to hand you back to Oleg. So Oleg, thanks very much. And thank you for your time.
Thank you, Roger. It was awesome. Now, staying on the subject of cloud, I would like to welcome Steve Gary from OneSite Solution. Hampshire-based company has been iSMA distributor for several years already. Their highly skilled team design and deliver and support cutting-edge smart building solutions from end to end. Steve will share his opinion on whether cloud management can replace on-site management and what drives the emphasis on a cloud-based system compared to the more traditional on-premises application. Let's have a listen.
Thank you, Oleg, and a big thank you also to Gc5 for inviting us to present today. I'm Steve Geary, Managing Director of OneSite Solutions, and I'm here today to present on my thoughts on whether the cloud can replace on-premise systems within a building. If you're not aware about OneSite Solutions and what we do, as well as being a distributor and a training centre, we also act as the master systems integrator, stroke smart buildings consultant on some sizable projects within the UK. We work directly with the main contractor or clients to ensure that all the data from all the different systems within a building is in a normalised and consistent format so that the data is smart building ready and in a position to communicate with the cloud.
So the agenda that I will follow today covers the following points. What's driving the change and what are the benefits that a building owner will achieve? We will take a look at the dependencies, so in order for the systems to be operational, what needs to be in place. We will then touch on other emerging technologies that will also add benefit and how they are disrupting the more traditional players. Early adopters have come from the home automation market, so it's worth touching on those guys as well. We will look at all the different languages and protocols that all the subsystems natively communicate with and what challenges this creates. We'll then move on to IoT overlays and how these can be used. And then finally, we will look at the likely outcomes and where we feel this will lead to. So what or who is driving the change? Cloud operating hyperscalers such as AWS, Google, and IBM have visions of replacing all site-based controls with cloud-based controls. The reason behind this is they believe their machine learning, artificial intelligence, and analytics modules in the future will be better placed to make decisions about the way a building operates to provide optimized control, better energy solutions, and improved staff and visitor well-being that can be deployed by all of the trade systems put together in a building. Models can be written, and with data continuously flowing to the cloud, these models will in time become tighter and more accurate based on the amount of data collected and the machine learning taking place. An example of this might be knowing exactly how long it takes to preheat or pre-cool an area within a building. If the cloud was collecting data from a variety of sources, such as internal temperature, external temperature, humidity, CO2, number of people within that space, etc., In time, it would be able to understand, based on that building's fabric, how quickly it takes to heat or cool that space. However, things will constantly change as people will move around that building or those external conditions change, so the model needs to keep refining itself to take that information into account. By knowing all these variables and getting the right level of control based on predictions will not only provide a better environment to work in, but will also be more energy efficient due to the fact that you will not be continuously overheating or cooling that area. In time, the building will be able to self-regulate based on all of the parameters that are being fed in. This is just one example of how machine learning can benefit the building. Imagine that you have data from all devices across all your systems, that an infinite number of rules could be written. However, if the data hasn't been presented to the cloud in an understandable format, it's highly unlikely to be done at a later date due to cost. That's why we're seeing literally hundreds of thousands of points being mapped during these projects we're working on, as clients are still not 100% sure of everything they want to achieve, but the more data they can collect, the better models they can produce. So it's easy to see the benefits for the building owners, as they can market the buildings to attract the best or highest paying tenants. But we are also seeing the facilities management companies starting to embrace the change, as the new technologies will reduce some of the manpower that they have traditionally had on site, and if they don't, they know their competitors will. Another plus point for the landlords that have large portfolios of buildings will enable them to see their best performing buildings and concentrate on the buildings that aren't doing so well. They can then take an informed decision on whether they want to sell those properties and remove them from the portfolio, or concentrate on taking them to the next level. Dependencies. In order to achieve these cloud-based systems, it's going to depend on IT infrastructure and system uptime. Clearly, a lot of the above would work, but what happens if the internet or IP infrastructure failed? It could still work, but local control would need to resume to take over with traditional controls methods. However, as we move forward into the future, clearly 100% uptime is becoming achievable to more users. Challenges to the above also come into play, like understanding strategy for things like heating and cooling systems. Do the cloud service providers know as much about these on-premise systems and how to control them? I guess over time, and we are seeing this, the big cloud providers are now engaging with building service trade contractors to understand more about how the building operates, hence learning the pitfalls and where the control and safety challenges await. Other emerging technologies. It is clear that IoT sensors and services are becoming more predominant with disruptive technologies. These are likely to be delivered as subscription models with cloud-to-cloud connectivity, lending the full cloud control to become more a reality. As more systems embrace the cloud, it will be easier to deliver data between systems at the same level and then send control and command down to the dumb endpoints. Here at OneSite Solutions, we're constantly speaking with companies within this space to evaluate their products, as it's vital for us as a business to keep up to date with the latest technologies. This enables us to better inform the customers and consultants for the projects that we work on. We can also review as a business if we have the right skill sets within our teams. And finally, we can better educate and support the SIs that we supply products to and train, as we clearly recognise these technologies will become a big part of their day-to-day projects. The home automation model is rolling out at a fast pace, such as lighting, heating control, doorbells, security, blind controls, smart plugs. The list is virtually endless. And the main reason that they are so widely adopted is due to the ease of configuration by the consumer, and they are extremely low cost. What we are seeing though is, although they are low cost, they typically come with a subscription model that generates a monthly return, as they are effectively cloud solutions that consumers are buying into. The smart home market was valued at £56 billion in 2022 and is expected to reach to £222 billion by 2026. That's a growth of over 25%. Therefore, it's no wonder employees are going to be attracted to work in environments that provide similar tech to what they have in the home place. We're also seeing one of the big drivers in specifications around the wellbeing standards. One of the ways this is achieved is to provide the user experience for services within a building through apps on the user's phones. In order to achieve this, cloud solutions are again required, along with the data from the traditional on-premise systems. Today's modern systems are starting to utilize IoT protocols as standard interfaces, hence MQTT, REST, etc. are starting to become basic features of major systems. Recent projects are showing that although BMS and lighting are already capable of delivering IoT connectivity, systems like CCTV, security, lifts and much more are adopting their standard offerings to provide a cloud-based solution and not the standard BACnet, Modbus, OPC type interfaces. Again showing that technology is driving the data into the cloud and generating a different revenue model. As you can see from the slide, over the past few years, in order for us to get data from all the subsystems in the top right of the page, they will typically communicate via one of the protocols in the bottom right of the page. We've had to install Iot Data Collectors, something along the lines of the iSMA MAC36 controllers, so that we can collect all the system information and then provide valuable metadata or tags against all the points. Without this information, the cloud-based systems would not know which points belong to which pieces of equipment. The data is then typically packaged up in a JSON payload and posted to the cloud with a high level of cybersecurity. However, as you will see from today's discussions, manufacturers such as Gc5 are adding these capabilities to the terminal units at the edge, so that the information will be configured by the engineers when commissioning the systems, and this, in time, will negate the need for the data to be double handled and should potentially mitigate mistakes in the data entry. IoT overlays. So with some of the disruptive technologies that are now flooding the building services market, simple plug-and-play configured devices can be deployed and located onto floor plans with instantaneous and valuable data about the areas they're deployed within. From indoor air quality sensors, desks, occupancy, and a whole host more of information can be quickly installed, mapped to a building's CAD layouts, and then viewed with pre-configured dashboards and associated analytics. In the image that we've got here, we've got an internal air quality sensor that we simply need to put our Wi-Fi credentials into. That will then automatically connect to the cloud solution and start posting up the data at a set frequency. You've then got the ability via using APIs of pulling that information from their cloud solution into another cloud solution. Alternatively, in this instance, we've then taken that to our data center and installed it into our own head end. You can then use that data to then make informed decisions within your system. Since the pandemic, and with the imminent return of getting staff back into the workplace, we have seen a big increase in inquiries of customers happily adding IoT overlays to their sites so that they can better manage occupancy within the building right through to understanding the air quality within that environment. This is probably due to the fact that a large number of wireless sensors can be installed and connected in a single day without the need for costly cable runs. Technologies such as LoRaWAN and Sigfox are able to communicate extremely long distances even within the built environment, making it more reliable than some of the older technologies. We have actually implemented this within our office space, where we've installed sensors to all our desks. Staff can then book a space prior to visiting the office, and if they don't arrive for whatever reason, the space will be handed back out for someone else to rebook. At the end of the day, the cleaners then have access to view what desks have been occupied and can concentrate their efforts of cleaning where needed. This also provides us with valuable information as to how the building space is being used. So what are the likely outcomes? We should probably expect that in the real world it will be a combination of both systems working to their best endeavours, similar to this discussion. Will machines replace man? The answer is yes, as they are more efficient, but man will still need to manage a lot of the processes. Also, the cloud will be able to be more efficient and make quicker and smarter decisions, but the on-premise systems will probably still be required to locally manage the safety aspects of an individual site. So to summarise, it's the hyperscalers that are driving the change, and to wanting the buildings to connect all their systems into the cloud solutions to take advantage of the machine learning and the analytics that are available to them. This in turn will then give benefits to the landlords, so they will have a more efficient building and be able to attract the best tenants to come into their spaces. But this is all going to be reliant on IT uptime. So the infrastructure needs to be in place and they need to have internet connectivity. We are starting to see, and we're going to see more and more of IoT sensors and services being put as overlays where all of this data can then be fed from cloud to cloud solutions. I think what we're also noticing in the drive of this change is the fact how our engineers need to work. It's not just a case of them now having to know about traditional protocols such as Modbus, BACnet, OPC. These guys are having to be more IT centric in around data transmission in MQTT and REST services of sending data out as JSON. We believe that the cloud will be more widely adopted moving forward, and people won't be wanting systems so much as on-prem. However, the way probably to look at it is that your cloud solution is going to be when your building's running at its absolute optimum. And for any reason, should you not have any cloud connectivity, for whatever reason that is, the building is still going to need to maintain a level. So you are always going to be reliant on some local control.
So thank you for taking the time to listen to my presentation, and also a big thank you again to Gc5 for inviting me to speak at their first iSMA Summit. If anybody has any questions regarding my presentation, or if you would like to know more about OneSite Solutions and what we do, then please come and find me in the talk room at the end of the presentation. So there's nothing more for me to say other than to introduce the next speaker. So here's Rich Costa from IBC, who's going to talk to you about evolving with technology. Thank you.
Thank you, Steve, for your presentation. Now it's time for a bit of history. Rich Costa from Intelligent Building Controls is going to look into past technologies, exploring similarities we see today in the BMS industry and his experience in BMS evolution. Intelligent Building Controls became iSMA distributor in 2018. The Irish company is the premier independent value-added distributor and solution provider of building energy management systems, controllers, and field devices. Rich, go ahead.
Hello, Oleg. Thank you for that kind introduction, and a special thanks to Katarzyna for putting the event together. Adam, thanks for the invite to the iSMA 2021 Summit. Just a little bit about my background. I've spent the last 35 years in the networking technology industry, with the last 15 years in the BMS market, watching technologies merge. I can't help but think to the past to revisit where we're at in the future, or where we're at today. I'll give you my take on BMS evolution, what's driving technologies of choice, product evolution, and then a quick summary. If I look back on when I started in the networking business, we had three major protocols that we were using at the time. One was based on Ethernet, 802.3, the other token ring, 802.5, and then ArcNet, which all had their features and differences. The main difference is the hardware technology. Ethernet was using a coaxial bus, token ring was using thick shielded twisted pair, and ArcNet was using coax as well. Applications then drove the need for faster speed, and 802.3 was the leading standard of choice. We fast forward to today, and we look at the infrastructure product. Ethernet 802.3 is now 100 base twisted pair running with Ethernet switches. BACnet MSTP is a version of IBM's token passing protocol, very similarities to the two protocols. And then you have BACnet on ArcNet. So they've added the application layer stack to the ISO standard. But if you see the choices for BACnet, the physical layer, there's a lot of different types of networking we can do. If we look back in my last 15 years when I started, all the systems were proprietary, supervisors were direct connected, BMS hardware was proprietary, and the actual communications connecting controllers were proprietary as well. The next stage was standardization of the communications. Since 802.3 led the way in speed, BMS products and infrastructure products started to adopt it. So we saw versions of BMS hardware with Ethernet. With that, supervisors then got detached from the BMS hardware and put onto the communications network, giving them more flexibility. Supervisors, BMS hardware, and communications are all all parts of the open standard. But we saw a lot of open standards, legacy standards like Modbus, MBus, KNX, LAN. They're not necessarily legacy, but they came out prior to the BACnet standard. But because BACnet is so tied to the Ethernet standard, it was very easy to use BACnet as the BMS protocol of choice. Then we fast forward to today where we're really talking about open systems and not standards anymore. An open system is where everybody's standards comes together under one umbrella. We see supervisors with N4 and BACnet communicating the BMS BACnet hardware, communications on the Ethernet with BACnet. And then we also see integration to Modbus, MBus, KNX, LAN, etc. So we see everything coming together under one system rather than multiple proprietary systems. And then to make it true open, we're bringing in legacy hardware with N4 drivers. So when we look at applications, we sometimes forget about to look at the physical media, how they're actually connected together. And maybe in the design portion of your BMS system, we should take more consideration of the physical media, such as Ethernet for the infrastructure and speed, RS-485 for flexibility and deployment, RS-232 for legacy and metering applications, and of course, wireless and the IoT and sensor networks. Pretty much anything with an 802.11 chip in it can now communicate via Modbus or IP back to the central network. And also you see a lot of Zigbee networks, wireless sensor Zigbee networks. Protocols also help define the application as well, because some protocols suit different devices better. Like for instance, energy meters are best suited for MBus because they're more battery friendly, and almost all energy meters are now deployed with a battery with a 7 to 10 year battery life. Modbus is the traditional protocol that kind of the first legacy IP protocol that came out. So you saw a lot of energy meters, chillers, CHP, fan coils, and package AHU, all in common. They all have powered devices. So the protocol doesn't have to be as efficient for those items. And then BACnet, of course, is just the latest, and it does almost all the same applications that Modbus does. And then you also have integration to DALI lighting systems, which again, another application requires a different protocol. So when we look at it, we have a flexible media deployment, whether it's twisted pair, whether it's IP, whether it's BACnet or Modbus or MBus. We all have choices now in deployment and finding the best wiring for the application to make the most cost-effective solution. I'd like to look at how technology is driving product evolution. I'm going to take three non-traditional products and that are attached to the BMS, but many people overlook them. First, from a metering standpoint, we look at the traditional meters, ultrasonic and mechanical. They're very inexpensive to buy, but the issue is they're very expensive to install. With any type of flange meter over 65 mil, you need to be welding these large flanges and then mating them to the meter. You also have to install, you have to have the meters prior to doing any on-site pipe installation or pipe testing or pressure testing. And then you have maintenance downtime. Although you have the extra expense of adding in isolation valves, as you see above, you still have maintenance downtime when you actually have to pull the unit out. So your system's down. Traditional communications is either pulsed or MBus. We see now the new insertion meters with the electromagnetic, with the smaller components, allowing you to fit more into a smaller area. They have a fixed cost from 65 mils all the way up to 600 mils. So you're no longer having to know the size of the pipe prior to the installation. you can actually have the piping installed and then design the meter after the fact. They're highly accurate, 1% of reading. Fixed cost for installation on all sizes. So you have one little small welded union you put on, and it's available in hot tap if the system is already filled. Once you install the isolation valve, your system's ready for pressure testing. There's no need for the meters to be on site. The meters can follow when the BMS is commissioned. And again, they allow you with no downtime by having the isolation valve. You can now do maintenance on the system without ever having to turn the system off. Pulsed, analog, Modbus, or MBus options are now available, so you have increased communications. As we know, COVID is driving more humidifiers into the marketplace and bringing humidification to the forefront. This is a revenue opportunity for a lot of different companies that may be controlling humidifiers, but actually aren't installing them. The traditional units, we see new technology coming out above and beyond the traditional units. We see them BACnet as a standard, so they're coming with BACnets on it, so you can get more data back to the BMS system. With the new condensing design, they're 10% more efficient than its predecessors. PVC venting for lower installation costs. Again, mechanical cost is key. So these units can be installed directly on the rooftop with an outdoor enclosure, or they can be vented through the side wall of a building with PVC. You no longer have to have stainless steel venting because of the high flue temperatures. Having a lower flue temperature is also part of the technology of the unit. It has a pre-warming tank that takes heat, warms the water, and then dumps it into the actual tank that boils for the humidification. They're ultra low NOx, so they meet all the latest emission standards. Any water type, so RODI or potable water, it allows you to create a redundant water system. So if your RODI plant goes down, you can feed it with potable water and know that you can still humidify. They have a smart drain technology that monitors the acidity in the water, so as it builds, it can do an automatic dump and refill. Then we look at the traditional valve and actuator technology, one output, one input for feedback and control. It has a high wiring cost because all the units have to go, you take up multiple points on the controller. So, and they're all home run points between the two units. The new network actuators from Control-E do require no points because they're all Modbus. And you get more information back from the valve and the actuator. Control, feedback, fault. It lowers the wiring cost because now we can daisy chain with the Modbus technology. And we have smaller panels because we don't have as many points in each wiring closet. And of course, there's more than 2 valves in a plant room. If you pair the same actuator with a PICV valve, you also have the capability of reporting the flow rate as well. On larger plant valves, they have a new smart actuator that can act as a PICV valve, an energy valve. It can control the temperature. You can use it to upgrade older globe valves with their installation kits. And then they're also Modbus connectivity. So there's 4-in-1 applications in one product. The nice thing about it is we talk about bringing computing to the edge. This is about as far to the edge of the actuator or the valve you can get. So in summary, we have now supervisors, legacy hardware, communications, software applications, new product innovations, all using technology in an open system with unlimited flexibility. So we have a completely open system. It's not just an open protocol. Thanks for your time, and I hope you enjoyed the presentation. If you have any questions, we can get together in the discussion rooms after the presentations. Thanks a lot.
Thank you, Rich. Now we are going to bring up the subject of energy management and analytics. Nick Cooper and Manoy Silvam from Forest Rock, iSMA distributor from UK specializing in IoT, smart buildings, smart cities and smart grid solutions, are going to introduce us to this topic. Nick and Manoy will highlight the benefits of SkySpark Analytics and Enfo energy management.
Hi, my name's Nick Cooper from Forest Rock. First of all, I'd like to thank Oleg and I'd like to thank Gc5 for inviting us here to join the summit today. I'm here to show you SkySpark Analytics and to run through how we set up the analytical platform and the benefits and features that SkySpark can bring you. So I'm going to share my screen and take you into the platform. You should now be able to see what SkySpark looks like. These are the apps. So above the line here, hopefully you can see the faint line. These are the apps that you're all going to be using. These are some of the classic apps that sit below the line here. And they're apps that have been used previously that are just left there so that you can use them if you feel more comfortable with them. But the latest versions are always above the line here. So whenever there's new features and benefits included, you'll see them all within these apps. So these are the apps that you should be using to build up your SkySpark Analytics platform. So whether you are new to SkySpark and it's the first time you've bought licenses, or whether it's something you've seen before, I'm going to try and give you a quick run through just to show you some features and benefits in a limited amount of time we've got today. What we'll hope is that you'll join us to understand more detail. We can give you more of a detailed overview of the platform and go into any specifics that might be important to you. So within the time that we've got, I'm just going to run through some of the apps and give you more of a high level overview of how it's all put together. So when you buy a license, this is what you get. You'll see whether you buy a small license, a 10-point license or a 100-point license, or whether you buy a 50,000 point license, you're going to get the same view that you see here. You're going to get these apps and you'll use these apps in the same way to start to build up your platform. So if I start to look at one or two of these and see what this might look like, if I go on to demo, just for the purposes of this, you'll see that there's always time related, time stamped. So you're able to pick out any periods of time, monthly, quarterly, so on and so on. And you can pick out by day, week, month. You've virtually got any calendar view that you want to see here of any byte of information. So if I just pick on something very simple, start to look at, there's an AHU here. We've got some discharge dampers and discharge pressures, and we've got these down here, which are sparks, which are events occurring. And one thing that you can do with SkySpark is you can drill in at any point in time. So I'm going to pick that, grade that out and drag that across, and that'll take me into more granular detail. You can do that with anything within SkySpark. So you've got that live view, and you can send this to people using the favorites tab. You can send all of your reports to people. They're all customizable. Could be a client who requires them. Save them to favorites in whatever format you feel is applicable, and they can view them, and they will view them like this in real time. So you can send it to a service engineer, somebody on site who's working for you. You want your bureau or your energy center to look at the information. That can be sent both ways, and you're both looking at it in real time. You're able to drill down and show them exactly what you're doing, and they can see what you're doing in real time, rather than on a document that's time stamped and therefore out of date by the time you've sent it. So I'm going to go through some of these just to show you what this looks like. We'll pick out a piece of time. Let's go for a month here, just to get a month's worth of data. So we're using the 4-block model in this instance. These are interchangeable. You see a lot of data here. This is kilowatt by site. We've got our 4 sites detailed there. We've got our 4 sites detailed here. This is just a block model. Here it is in a pie chart, and here's the information on a heat map. So you can change this for any piece of data that you want, any look and feel that you require. Start to build up site reports, which we'll come on to here. But this is your data. As I said, let's just move that out of the way. You go here to favorites. You save the view, export, and you can drop that into an email and say send it at 4 p.m. every Friday to an energy manager or your client, and they'll get that report. You don't have to keep formatting the report. You do it once, set it up, give it the right look and feel, send that information off to client, or send it in real time over in whatever format you see fit. So if we look at the equipment, let's pick a site. We see our 4 sites down here. Let's pick a piece of equipment. Just go into this. Let's get a period of data. Again, let's maybe go for a month. Start to see some data coming through. Let's put the weather on. This is important. The weather comes with it. So when you buy a license, you'll get the weather included. There's a weather feed built into SkySpot. This is important. Obviously, if you're looking at things like degree days and benchmarking of various sites in different locations, you want to know what the weather was like as an able to you to normalize data. And I'll show you what that looks like shortly. So let's put the weather on. Then you'll start to get more detail, and you can see what the weather looks like over this period of time here. Again, you can pick out any period of time. You can drag that across and just go into more detail, more granular detail, and you can see what that starts to look like. So that's just a piece of equipment. In this instance, a meter. You just picked out one piece of equipment. You can go back here. You can add in anything else, adding any other pieces of equipment that you see fit, and just build on that. And of course, you can just use this to toggle between various months, days, weeks, etc. So let's just have a quick look at a site report. This is just a really high level overview here today. So it's I'm running through at a fair pace, but let's pick on a site. You'd add an image of the site. This is a kind of a 3-block model that we're going to put data into. You can have as many as 9. It might look quite detailed, or you can add other pages, but it's all customizable, and you decide what you want it to look like. So let's pick a stamp of time and add that in, and then it will build. So we've got a heat map again. We've got charts. We've got data here. Again, if we wanted to drill down, and it's that simple to go into that in live data format. So these are our site reports. Let's have a quick look at one other. Let's pick, say, headquarters, very grand building. Okay, and then again, more data, more detail. Build the site reports up, as I said, all customizable. Save them in whatever format you feel is applicable. So a quick look at the Spark report. We're in demo mode, don't forget here. So this is just showing you some of the possibilities that are available, or some of the features within it. Let's look again. And these are sparks. So these are all instances. This is something's happened. This is where you want to be guiding your engineers to look into, to drill down into this information, find out what's happened, and SkySpark will show you that. People use it for their own service and scheduling. They use it to look at clients' details and deep dive into the site before something necessarily happens. They use it to build up their own maintenance visits based around what's important, what's meaningful. There's a couple of other tabs on here. These are just around tenant billing as well. I'm not going to go into the detail today, but these are all available. So let's just go back. Let's pick on something fairly simple to use. So say the energy app. We're going to go all sites. We're going to put some data in there. Okay, let's just stick to a month's worth of data. So if we did something like this within the energy app, we get this sort of view. This is just a real indicator, high-level indicator of the sort of thing that you can do. It's really quick and easy. SkySpark's been designed so it's just a couple of clicks to do anything. It's really easy, intuitive, simple to use. If you're looking at this, you'll see the blue areas here, the peaks. This is our headquarters. So this looks like our problem child. Looking at this, it's our biggest energy user. We think, well, okay, so we need to dive into some of this and see why. So we can do that again, but that's not really showing us a great deal. Let's click on a couple of the options to see where we can get to. Well, for a start, let's put it in. Let's change the look of the chart to something simple. You can use any of these, as I said, every time you get this option. It depends how you want to display it. So let's put it in a bar chart. Just make things simple for a second. Right, so we've seen that headquarters is the biggest energy user, something like 719 kilowatts up there, down to 387 in Carytown. This is our big energy user. So automatically we think, well, that's our problem child. But let's start to have a little look just by normalizing some data. And you can do this with these pre-built normalizations, or you can add any number that you feel are fit and applicable. So now we're going to go by area. All of a sudden, not our problem at all. Carytown is our problem. So by area, by mass, headquarters is not our problem. Very quickly, let's add the next one in, degree days. So now we're using the weather data. And there we go. It's definitely not our problem. Using those two normalizations only. We can change that. We can take out days. We can baseline it. So let's look at the previous year. Let's see if there's any kind of obvious problems, either up or down on previous year or previous month, whatever we want to do. Start to baseline things. It's very similar on headquarters, not too dissimilar on short pump. Gaithersburg is exactly the same. We've got a bit of a shift here in Carytown, so we need to be looking at this. Okay, so previous year, baseline May 2019. All right, so this is what we're looking for. We're looking for anomalies, we're looking for shifts, we're looking for patterns. This will show us. SkySpark will go straight to it. We need the data. We look in here, add normalizations in, baseline things, take out various days that are not applicable, take out weekends or holidays or whatever it might be. It's all available within SkySpark. I'm not going to go through all of the tabs for now because we're going to run out of time. And just an overview. I just want to go through the apps really. So let's just have a look at. We looked at the energy app. Let's look at a KPI app. Set up KPIs. So you can start to look at things like I want to reduce energy on prior year, and you KPI that. You can go through anything that you really want to in any format you want to see things and just add them in. And then we can add different rules. We can add different options that you've already seen. I'm going through at a bit of a pace really, but one other thing that's really meaningful is about the sparks. That's where it got its name. That's SkySpark for you. So we'll go all site. We'll go from onto data again. The sparks are an issue. The sparks are where you really want to get into the detail. What I'd like to show you is that you can apply costs. So you can see what's really meaningful in terms of cost. It's costing you not to put something right. And this can really guide your engineering team or the energy manager or client towards finding the things that are going to cost them money and putting them right before it becomes a real problem to them and a real issue, and deal with it very early before it becomes an issue. So one we've got here, nearly 2.5 days. These have been lights on and unoccupied, for instance. There's a little information button that tells you what recommended actions there are and what sort of priority. And again, they're all interchangeable. You might think that's a high priority. You might change some of the actions, but some of these are already built in for you to use. If you go onto the sparks themselves, you can see things here, short cycling, things like heating and cooling coming on at the same time. Very simple things that you give your engineering team an opportunity to drill down into. If we just look, for instance, look at a rooftop terminal unit, this one here at Carytown, we just click on the arrow here, and then we're into the equipment. So that will take us via this all sites, Carytown, rooftop terminal unit 1. Now we're right into the equipment, and we've got all of this detail here, all of this data. Again, you can change the months, days, weeks, go back through this. You can add in, we've got the weather on. We can add additional points into here if we want to. Let's not do that right now, but we can add in any points that we think are relevant to this particular piece of equipment, a rooftop terminal unit in this case. And we can really get into more and more detail. So we can go to understand where the problems are arising and drill down into any of those at any point in time. So if we go back to all sites, let's look at the view again. This is really, we really want to do our work. This is the Spark app, as we showed you. You want to be in here looking at this and understanding where these sparks are coming from. In an ideal world, there'll be no sparks, but it never happens. So as soon as you add equipment, add points, you're going to get sparks, you're going to get issues, and SkySpark is going to find those meaningful issues and sparks for you to deal with. The way that you do that, you set up rules, add rules in. They're already predefined rules within SkySpark. You don't have to write your own. They're customizable, so you can change them as you see fit. And then also you add a connector. That connector could be something like a Jace. It could be a small Raspberry Pi device. It could be a trend controller. It can be anything that you're using as a connector, as Sky Foundry call them, a connector, which is how you connect those points or that piece of equipment that you're going to pull into, or that SkySpark's going to pull into this analytical software. So in terms of setting up, you need some rules. You use haystack tagging. You need a connector. You will need a server. That could be a cloud server, yours, your clients, ours, another, or an on-site server in the simple way, or belts and braces and add an on-site server and do something at the edge as well. All interchangeable, all totally down to you or your client, how you want to see data, how they want to receive data, and where data is stored. So simple to use, simple to set up, and simple to operate. Let's stop sharing. Just to say, to finish off, thank you for your time. I do appreciate anyone who's taken time to look at the video. We're here to try and help you, guide you through the SkySpark Analytics. We will go through in more detail. If you want to make an appointment, please do so, and we'll give you our time to go through any questions or any particular parts of SkySpark that are of interest to you or the platform. And then just to finish off, I'd like to say again, thank you so much to Gc5, and thank you for the opportunity to be able to present today. I hope you stay safe, have a great day, and I hope you enjoy the summit. Thank you.
Morning, everyone, and thank you, Oleg, for the introduction. Today, we're going to be looking at Enfo Energy Manager, an energy management platform built on the Niagara framework. It helps you analyze metering data, build reports and dashboards, and raise alarms with your metering information. That could run on a Jace, supervisor, or embedded controllers, which supports the Niagara framework. It could be retrofitted into your existing BMS if it runs the Niagara system again. It's easy to engineer. The dashboards are customizable, and the color schemes and the layouts of the dashboards could be catered to your end customer's design requirements. Has out-of-the-box integration with various protocols, Modbus, BACnet, MBus. Also comes with lots of utilities to import CSV files and exports from energy suppliers into the system. We could also export data out of the system in PDF formats or CSV, which contains processed metering information. So let's have a look at the dashboard. So this is a dashboard we've put together for the demo. We also ship this as a reference implementation when the customer purchases product. So we'll look at the bar chart here, and all charts follow a similar sort of a design pattern. So we'll have a look at the bar chart in a bit more detail, and the remaining charts would follow a similar pattern. So you have a title, subtitle, and I have a time series navigation, which is very unique to Energy Manager. It helps you jump across different time ranges easily. So in this case, you could jump between a day, week, month, year, and 5 years. The pound symbol, that is, every meter has got a cost profile associated with it. And when you hit the pound symbol, we calculate the pricing information for that meter and display it on a chart. Have a few options to export what you see on the chart as in different formats, a CSV file, PNGs, PDFs. And when a customer opens up a dashboard, this is what they'd see. And if they wanted to add more data points onto a chart, they could do that using the data config dialog, which lists all the data points, all the meters available to an end user. So if you add the outside air temperature and click save, we can see we have the outside air temperature alongside your kilowatt hours. You could also choose different time ranges to be overlaid on top of each other. So in this case, we've got current week's information and last week's information overlaid on top of each other. But you could do current week, last week, current month, last month. You could do current year, last year. So the remaining charts are different chart types: a line chart, pie chart, a ranking chart. So this chart always sorts the highest consumption, the building with the highest consumption to the top. So it's like a leaderboard across your entire portfolio of buildings. We have various other dials, a group of dials. So in this case, it's used to represent energy information, but this could be representing any numerical quantity. Another interesting UI element is the heat map. So this represents 365 days worth of data, 365 days, 24 hours worth of information. So here it's bound to a temperature sensor, so you could see the seasonality in the data. You can see the winter months and the summer months. Have a kiosk mode. The kiosk mode is something which you would put up on a TV in your reception or in the canteen. So this flips through different pages with an interval. So every 30 seconds it'll show a different page, and the page could contain energy information or today's news or Twitter feed, for example. So again, all the layouts and the interval between pages, it's customizable. And let's have a look at how a report is built. So we have a report builder, which helps with building reports. So all the charts we've seen can be added onto a report. So if you were to design a report, you would pick and choose what elements we want to add onto a chart. And if you wanted the tabular data to be shown in a report, we toggle and we get the tabular data as well. So once you've designed a report, you could save it. And this report can be generated periodically in the background and sent out over email, or be stored in the file system, or sent out to an FTP server. So this is how a report is built, and this is a PDF report. We could also design CSV exports, which exports energy data into an Excel file for analysis. The Excel file could have other formulas and scripts built into it. So to give you an example of what a report looks like. So once a report is generated, so this is a PDF output of the report we just designed, and we could also lay out the report as an energy bill, for example. So this report is generated using data within Energy Manager to format a bill. In this case, again, all of these reports can be sent out to different destinations. So that's the reporting element of it, and just a general overview of dashboards. Thank you for your time and attention. If you have more questions, please do feel free to reach out to us. Thank you.
Thank you, guys. Great presentation. Let's move on to the next topic, which is data acquisition and handling. It's going to be introduced by Paul Rogers from Tridium. Paul is an experienced international sales leader, B2B product and marketing manager with the construction, renewables, and IoT sectors. Paul is going to discuss market trends and solutions to meet the growing demand for data capture, processing, and consumption as a result of IoT implementation. Let's start.
Hello, everyone. Thank you, Oleg and Gc5 for allowing me to participate in this conference. My name is Paul Rogers. I head up Tridium's global business development team. We have a team in the US, EMEA, and APAC. And today I'm going to talk to you about acquiring data and what you can do with that data once you've got a hold of it. So let me just share my screen. So data acquisition and handling, and this is from the point of view of Tritium, and we're the makers of the Niagara platform, some of the things that our customers are telling us, some of the trends that we're seeing in the industry, and some of the solutions that we've seen are available. So I just wanted to talk about the volume of the data. So the question is, how much data is there in buildings? And the answer is there's quite a lot. More data all the time is being recorded. There's an increasing amount of edge computing, and even device manufacturers, chillers, boilers, CCTV, all those equipment are getting smarter at the edge. They're having more advanced controls. They're doing more at the edge. They're capturing more data, and they're doing more with it. So when I've just done some research on the amount of data in buildings, and I've got three interesting graphs. So we look at the total volume of data inside of buildings. Right now, it's standing at about 35 to 40 zettabytes, and a zettabyte is 1 trillion gigabytes. So that's a lot, right? If we look at the total amount of digital data in the world, it comes to, according to some reports, about 175 zettabytes. So of 175 zettabytes, buildings alone represent 35 to 40 zettabytes. If we look at a medium commercial building, we can see the processing power needs per second could be, in a medium-sized commercial building, 512 terabytes per second of processing power for all the systems dotted around. These are the BMS, the CCTV, the access control, the field devices, all churning 512 terabytes per second. So that translates into, and this is from science papers that I've been able to get a hold of, which translates to a 50-floor commercial building, and the data generation per day, 44,280 petabytes. Now, I don't know about you, I'm used to gigabytes as being the biggest, or one of the biggest storages, and maybe a terabyte or two. But zettabytes are just a huge number, 512 terabytes of data flowing through the building. It's a lot of data that's out there and flowing around. So what's driving this data? Well, don't forget, a lot of it's already been there for a long time. It's just never really been captured. So, a vapor compression cycle in a chiller will have data flowing through the system. It's not necessarily recorded, but it's there. Now, what the baseline of that data is before this new IoT dawn, I don't know. But there's already intrinsically a huge amount of data on those systems. Some of the new drivers, I think they're very common to everyone on this call. Customers want to have a single pane of glass. And the driver for that is an end user will know very well how their business is run. They know exactly how much they pay on payroll and paying staff. They know exactly how much it costs in raw materials to build a product or to build a piece of software. So on their P&L, on their costs, they know as much information as they ever want to know. But when you look at the building cost, it starts becoming a bit of a black hole. So they know they spend X amount of money on CAFM, and they know they spend X amount of money on the FM itself. They know they spend X amount of money on energy consumption. But she might not know how much energy she's spending exactly on energy. Why is it this figure and not that figure? What business activities change that energy consumption figure? Purely looking from a CFO point of view, she would look at that and say, I don't know. It's a black hole on the P&L. So a single pane of glass gives you an ability to try and bring all that together. And it's not necessarily just building data that we're all used to, defaults and alerts and temperature settings. It's also things like well-being metrics and KPIs. It's information that a CFO might want to have, or maybe even a marketing manager might want to have. How many visits per day? How many times are people using different areas of the building, smart spaces, things like that. A need to understand that data to pump information into the single pane of glass is being provided by AI and machine learning. They're not the same, although it does confuse me why they're not the same, as I think a lot of people on the call. But you know, these data churning things are out there, and they want to consume as much data as possible. They want to consume current data, predict future data, and also consume maybe even 10 years worth of historic data to get an understanding of what is happening, why it's happening, and what potentially could happen next. Insights from the data are highly sought after by an end user. And the insight really means I'm spending, a CFO might say she's spending 50 million on energy consumption for large manufacturing facilities. Why are they spending 50 million? Can they spend 48 million and achieve the same result? Or are they getting a poor result of product because they're only spending 50 million? Do they need to spend 52 million or more? Why is it that a boiler will fail at this particular time and not this particular time? The way we run facility management is almost like reading astrology. You have your 2 or 3 regular visits a year, but there's no indication of whether that's suitable or not. You should be looking at how the equipment is being operated and adjust your facility management around that. If it's a standby power generator, does it need to be maintained as actively as a duty power generator? Business models that are entering the smart building space that are historically not been available before, but are now becoming more attractive, is the as a service. So I've seen some equipment manufacturers, boiler manufacturers saying, I will give you this as a service. And that's quite an interesting proposition. You don't buy the boiler, you buy it as a service. IP at the edge is another thing that has opened the floodgates of potential possibility to churn data at the edge and pass it through systems. So just speeding along, this is an example of a network architecture that I've seen. It's a bit of an extreme example, but there's a whole new gateway market becoming available for people. We're seeing applications in the cloud. We're seeing cloud-to-cloud connections with APIs. You could have an IoT device manufacturer with IoT devices in the building, and it would need a gateway. The gateway sucks in that data, puts it in the cloud, and then that data needs to go somewhere else, to somebody else's cloud. If you're doing cloud-to-cloud integration, you can do it with APIs. You can also bring the data from the cloud back down into their own servers on their building. Effectively, a server inside of your own building is your own mini cloud. So you could share the information that way. And that's something relatively new. Cloud was all about storage and maybe large data processing, but now you have cloud native applications that are being deployed, and a cloud first understanding for rather than the traditional way of on-prem and maybe a cloud option. We see MQTT and JSON being used quite often in specifications to package the data in a JSON format and send it via things like MQTT. So the challenges we see, and they're everywhere, traditional challenges of siloed systems and the cost upgrade are common now as what they were 15 years ago. But another challenge is old things on site. So chillers, centrifugal chillers or boilers, they can last for 25 years. But if they're maintained well, they could last 35 years, especially some of the bigger stuff in industrial applications. Now, these are things that mechanically perform very, very well, but would need some kind of integration tool to extract the data out of their proprietary system, normalizing it and bringing it into the IoT. There's no reason why a data point ages. Just because a data point is floating around in a machine that's 35 years old, or even 50 years old, that data point is just a piece of data. It doesn't age with the machine. So getting it out shouldn't be a problem. So you could have an IoT ready device that's actually 50 years old, as long as it has a decent controller of the side of it that can talk to it. Another problem is the data is dirty. Machine learning can't read the data. If you have an installation engineer calling a light_1F_003, is light number 3 on the first floor, but someone else could label it differently. So the light first floor _3. Machine learning really struggles with understanding what that is, and it'll probably register those as being 2 different lights, even though it's the same light represented potentially on 2 different systems. So we do see a requirement for data tagging. The final challenge is the Iot Clash, and this is something we see often. I think it's a massive opportunity for MSIs, for partners, for consultants to fill this gap. There's a big void between the IT world and the OT world. And the OT world, they have their own standards. They have pressures of getting things to work, making sure the building is operational, making sure the doors open, making sure the water is clean, making sure people are comfortable and safe. And the OT world have their own pressures of cybersecurity, of data cleansing, of network traffic and bandwidth, data storage, data backup. 2 very different standards, 2 very different set of KPIs and objectives, and these 2 worlds are clashing. There's generally, I think, a poor appreciation on both sides of the fence. It's a common misconception that people would say, well, the OT world isn't educated enough to understand the IT world. The reverse is also very, very true. There's a reason why you have 2 pumps on a system when you only really need 1. You have a standby and you have a duty. The IT world doesn't necessarily understand that, and machine learning really doesn't understand that. So there is a learning gap on both sides of the fence. So from a Tridium point of view, our solution has been, number 1, portability, allowing third-party companies to have their own hardware with Niagara on that. The reason is we know very well that although the Jace, our own hardware, is a very good product, it might not be suitable for all applications. So rather than us making different flavors of Jaces for different applications, we think it's better to allow our partners to do that for us. So you have Jace versions with onboard I/O. You have Jace versions that are built for the industrial sector, Jace versions that are hardened where you can roll a truck over it. We are invested into haystacks. A common data set in things like Niagara does allow you to have the control mechanism. Normalizing the data is one thing, but controlling it is certainly another thing. We deploy JDBT and MQTT, and we have just started doing our own API. For us, it's about extraction, tagging, normalization, transport. And customers have the options to do all of those 4 things in any way they want to do it. And then finally, this is what I advise to customers. And some of our customers are the biggest global tech companies in the world. Some of our enterprise customers have a large footprint of buildings. But we always advise them the same, because they have a wish list of what they want. But we say, well, look, decide what KPIs you're trying to achieve. What is it you want? Are you more interested in comfort, or are you more interested in energy savings, or a mixture of the both? Is well-being high on your agenda? Then, once you decide your KPIs, go and extract the data that you have, because the reality is you have most of that data available. If you want to know how often people use the bathrooms, don't be in a rush to put in a sensor, because you probably have an automatic lighting system in there already. So if you have the lighting system, extract the motion data from the lighting system, not necessarily by putting in another LP1 sensor, for example. And then once you have all the data that you can get, fill in the gaps. So if you want to know something that your current data can't give you, go away and add new sensors and fill in that gap. So that's it from me. Look, thank you for listening. And thank you to Gc5. It's been a pleasure speaking at the iSMA Summit. Thank you.
Thank you, Paul. It was really great. And now it's time for Gc5 representatives. Let me introduce Marcin Płoski, Vice President of Business Development, and Monika Musielak, Solution Manager. They are going to show us a future powered by iSMA Edge. Monika, Marcin, please. Good luck.
Thanks.
Thank you. Thank you, Oleg. Welcome, everyone. Thank you very much for joining iSMA Summit. Today, together with Monika, we are going to present a future powered by iSMA Edge. At the first stage, we would like to present you the very soon coming new products, Edge iSMA. Monica, please, the stage is yours.
Thank you.
Thank you.
As Martin mentioned, we are releasing 2 new products this year. First of them is the wall panel, and second is UAC 18. I will talk about them in next slides. New line of wall panels was designed for temperature, fan speed, and occupancy control. Modern design of front glass panel hides capacitive buttons for seamless use. The size, 86 by 86 millimeters, perfectly fits the standard electrical box. Wall panels will be available in black and white option, and with or without a display, which will show information from sensor. There will be a possibility to choose from 4 configurations of temperature, humidity, and CO2 sensor. You can communicate with the panels using BACnet MSTP or Modbus RTU. For easy and fast connection with UAC 18, the product will have RJ45. This connection will provide both communication and power supply to the panel. UAC 18 stands for Unitary Application Controller, with 18 inputs and outputs in total. You can find there 4 universal inputs, 4 digital inputs, 3 analog outputs, 2 triac outputs, and 5 digital outputs. It is a freely programmable controller designed to control small HVAC units. There is a thing implemented in the hardware that was never implemented before. 2 Ethernet ports that are fail-safe protected, that can work as a switch. Why fail-safe protection? To keep the continuity of data transmission through the device, despite of possible supply breaks. There are 2 RS485 connectors. RJ45 to connect the wall panel I presented a minute ago, and a screwless connector for connecting other RS devices. Last but not least, the heart of the device is an SD card, which contains all software elements. In case of hardware failure, you can take out the SD card and move it to a new hardware. Both products will be released at the end of this year. Now Martin will join me for a little demo presentation.
Thank you, Monica. Okay, before we start demo presentation, I think, Monica, we should explain a little bit more about what do we have on the table. So what do we have actually on the table, Monica?
At the start, we have 2 sets of UAC controllers with wall panels in black and white version. Also, we are showing the possibilities of communication between the UAC and the panel. Here we have RS screwless connector, and here we are using RJ45.
Okay, but I can see the second UAC 18 is not power up. Why is not power up?
To show you that the fail-safe protection in Ethernet ports is working. So even though this controller is not powered up, the communication still goes further to the next device.
Okay,
Martin.
so even there is no power supply, the communication signal goes through this switch without power supply. Okay, that's brilliant.
And
okay.
Martin, what do we have here?
Okay, so here on the left-hand side, we've got MAC36, which is our master application controllers, together with the HDMI display connected through HDMI cable, and that works as a small size or mini BMS system. So what we want to show you here today, we want to show you how simply UAC 18 can be connected, our iSMA Edge devices can be connected to standard BMS system using our MAC36. But I can see as well on the table there's a black box. What is that black box all about it, Monica?
This is our cloud. So you're not only connected to BMS, but also to the cloud.
Okay, so now we wanted to present you how our edge ISMA devices, they can be on the same time part of the standard BMS solution, which is this bit, and on the same time, we can get the data back to the cloud. So our cloud is the black box. Okay, so let's start a demo presentation then. I will need my laptop and some software. Okay, let's get prepared this stuff. So, okay, let's start some demo presentation. To be able to talk to our ISMA Edge devices, we developed a dedicated tool, which is iSMA tool. And now I'm going to use the iSMA tool to see what is inside. So right-click on the device with IP address. Now we are connecting to the device. The good thing about our system is you don't require any modules, any software loaded on the local machine apart from the tool. All the rest is loaded direct from the device. So now we are inside the device. As you can see, in the device, we've got four main containers: application, network, service, and system. I will just briefly explain what is each container. The application container is a container where you put the application. You can have many applications in that container. Each application can be set up with different scan periods. Our application in a system, they are cycle-driven, which means they are executing every certain period of time according to the scan period. Each application can have, of course, different scan periods. So it doesn't have to be all the applications, they need to run on the same scan period. You can see that the scan time is actually physical time required to do the application. The equipment application is empty application, I believe, but the My Demo has got few components, and as you can see, the scan time is about 4 milliseconds. It's very fast system. The next container is a network container. Under that container, we add network communication protocols. So because the system has been designed to be natively ready for BACnet and Modbus, that's why by default we've got Modbus and BACnet protocol. And of course, we can see here we've got local I/O. Local I/O is a dedicated network protocol to allow us to get data from inputs and outputs. And we can see here is a haystack service. I will tell a little bit about haystack service in a minute. The next container is a service. At the moment, we didn't install any services in this device, but this is the container where normally you install services like email, SMS, alarms, trends, and so on. The last container is a system. System is a container where you can find all the information about physical hardware. For example, in platform there is an information about the device name, it's about operating system version, number of inputs and outputs. So whatever is linked to the hardware, physical hardware, you will find under the system section. Okay, let's go back to the presentation. So this is the brief explanation what we have. Of course, I will need much more time to be able to tell you much more details, but we are limited time. So we prepare, under the application, we did prepare a small application which is simulating the working of fan call units. And as you can see here, we've got the few components. The main components in our system are data points. The whole system is based around the data point. The data points, they are components which can be exposed. You can bring the data into that component, and as well, at the same time, you can expose this data into the different systems. So, for example, if we have a look on the analog data point, which we've got here, on the right-hand side, you can see this is very simple component with one input, input number 16, output slot, but has got many extensions. And those extensions, they are dedicated for external communication. So, for example, we've got BACnet extension, haystack extension, and Modbus extension. What it means, actually, it means that this point, once it's added to the system, is exposed automatically over the BACnet, Modbus, and haystack protocol. So let's do some tests. So Monica, can you please change the set point on our black NSP panel, please? Okay, so Monica change the set point. This is something. Okay, let me make it a little bit bigger. So we do receive is 24 Celsius at the moment. Of course, we can change the set point from here, but this is not what I want to show. What I would like to show you that this point is exposed over the backnet. Next, we've got Niagara software. In Niagara software, as you can see here, we add under the backnet driver, we add the UAC 18. And if we go to the UAC 18, the graphic page, you can see it's 24 degrees Celsius here as well. So whatever we change on the NSP black panel, this value is driven through RS-485 to UAC 18, and UAC 18 expose this data over backnet protocol. So, for example, the supervisor or Mac36, which works in that case as a mini BMS solution, can receive this and display on the graphic. If I'm going to change now from the graphic, because the end user can as well manage the site using the Mac36 or supervisor, ISMA supervisor. Now I changed it to 22, and I believe, Monica, can you confirm if this is the 22 on the NSP? We have. Let's have a look on our ISMA tool. Yes, we can see there is a 22. So we just show there is a synchronization between standard device sits on RS-485 going to UAC 18, which is IP, and from UAC 18 going to Mac36. Now, what we want to show you as well, this bit, this bit which I just explained, is a standard application which is going to be part of the standard BMS network. But our edge devices, they are ready for IoT connectivity. And we've got here on the table black PC. Black PC, on the black PC, we've got Linux operating system where we install SkySpark software. So let me go now to the web browser. And as you can see in the web browser, this is the SkySpark software. So we managed to add the device as a haystack device with already tagged inside. So what it means that every single data point has got an option. Sorry, let me go back to here. Has got as well an option of tagging. If we go back to the extension, haystack extension of that specific data point, you can see there are tags. Of course, we can change the tags. We can add our tags. We can choose the tags from the haystack library. What it means? It means that if once we save this, once we add the point and we set up the tags, then those points, they're gonna be visible as a standard haystack points over HTTP protocol. So, refresh, I just go back. Loading, there's some, I think there's this device is power off. Monica, is that PC is on? Switched off. Okay, so let's wait for the reboot the black box, the SkySpark server. But in the meantime, once we're waiting, okay, it's quite fast. Okay, so we've got it. We are back up and running. Okay, so you can see it's 22 degrees. So Monica, can you please change the set point on NSPC if we can receive those changes? So 22, and you set up to what, 23, 21? Okay, that's true. So as you can see, now we showed you how these ISMA edge devices, they can be used on the same time as a part of BMS system together with some cloud connectivity, cloud software, like in that case, it's a SkySpark. Let me show you one more thing here using the standard web browser. So for example, here we've got the HTTP standard web browser, and what we managed to do as well, we simplified the process of tagging. What it means? It means that, for example, every time I'm adding some new application, let's duplicate that one and let's call it ISMA Summit. So this application, ISMA Summit, when we go inside, there's one data point. So now I just add the simple application, the new application with some data point inside. And now let's go back to the HTTP haystack. If I refresh the web page, you can see that straight away after I add this equipment, over the haystack, there's a new equipment visible, ISMA Summit. What it means that there is no additional work requirement to be able to expose data. Everything is natively. So that should simplify the process of getting connected the ISMA Edge to both systems. From one side to BMS system, because you notice this is automatically exposed through Modbus and BACnet, and on the same time to IoT connectivity to system in the cloud. Okay, I think that's all what I want to show you. Of course, there's much more we can show you, but there's a limited time. So now let's go back to the presentation. The next step I would like to talk about it is the future of ISMA Edge. So we are now where we are going to release two products, UAC 18 and the new series of wall panels, which Monica explained to you very deeply what those products they're gonna have functionality. I did show you the environment which is built in, so you can do quite a lot of different things with these new devices. But this is not the end of our journey. This is just the beginning of our journey. The next step we want to do it is we want to focus on more development in UAC 18, and we would like to develop the UAC 9, smaller devices dedicated for fan call unit. On the same time, we would like to expand the wall panels portfolio, because this is something which will be required in the standard COFO management solution. And as well, we would love to focus on the VAV controller. So I hope very soon you should be able to receive the controller dedicated for VAV or CAV boxes. Parallel, we want to work very hard on the DDC solution. So we are planning to develop many versions with different type of communication interfaces. The new range of DDC AAC20. But this is not the end. The next step, we want to do it once we get finished those hardware. We would like to going even further. So we are planning to work on the wall touch panel, nice color touch panel, together with some ceiling multi-sensors. And of course, there is a plan to develop the VAV controller with built-in damper actuators. Regarding the DDC solution, we want to expand the portfolio by adding the display, built-in display option, and as well the external display, as we can see here. And once we achieve that, we would love to bring, because this technology we just shows you, the Edge, ISMA Edge, is a software which can be implemented on a very small piece of hardware, and we want to put that technology into I/O modules as well, because we can see a big potential that the I/O module is something which is required today, and it will be required for tomorrow. But I think we think all together, we believe in Gc5 that the creating IoT I/O module is a next step for I/O modules, and of course. There's as well, there are some plans for creating some gateways, like, for example, BACnet gateways and some other gateways. And once we finish this journey, we should get very big, nice portfolio of different edge devices dedicated for different solutions. And they will be not only part of the BMS system, but they will be by default ready to be part of IoT. And that's all about today's presentation. I hope you like the presentation, and I hope we can talk soon, and some of you maybe we will see face to face. Thank you very much.
Okay, that's all we have prepared for you today. Thank you to all the speakers for the great presentation, but stay with us, because now you have the opportunity to talk to us and our distributors in special virtual rooms. Our distributors will be available for about an hour. You can also ask them about special iSMA sets we have prepared for you at the very attractive prices. I would like also take this opportunity to announce and invite you to the next iSMA Summit in September. This time prepared together with our distributors from the USA and Canada. Follow our website ismasummit.com and stay in touch with us. Thank you and see you in a while in a virtual room. Bye bye.